Now, we just summarise calories, one column. But if I wanted to do the summary data table for the paper, I want to summarise all the columns. So I go to Analyse and Descriptive Statistics and Explore. And instead of having calories, I put in protein and fat and sodium and fibre, complex carbs and sugars and potassium. And I press OK. So now it gives me a single table which has all of those different things in it. The mean in calories is now 107.0270. But before, when I did it, it was 106.8831. What's going on here? So what's going on here is you've got a different data set because of those missing values. So before, it processed 77 cases. Now, it's processed 74 cases because it's gone through the data set and found if there's any column that contains a missing value, it removes that entire row from the analysis. Now you can change the way SPSS behaves so it doesn't have to do that way of dealing with missing data. If you'd done each column individually, it would only exclude the number of rows which are missing in that one. So if you did the potassium one, it would have excluded 2. If you did complex sugars and complex carbs and sugars, it would have excluded just 1. So depending on how you calculate your means and your confidence intervals, it's going to be different depending if you do them all together or one column at a time. So you have to be aware of this. Now, when you're summarizing your data, you have to think, which do you prefer to do? So you're going to have a data table. The top thing will say number of cereals you studied. So you say n equals 77. But there's some parts of the data where n doesn't equal 77, it equals 75 or 76. Or if you summarize them all together here and exclude all those 3, then n equals 74. So you have to make a decision. Now your decision will depend on, do I need to include every single one of those columns in my analysis and summary data table? What is my question? What am I actually trying to study? And how should I do it? So this is to tell you that when you do data analysis, there's no one unique solution. So people go, well, if there's so many different ways of doing it, how do I know that I'm doing it right? You're always doing it right if you tell the person who's reading it what you did. The only time that statistics becomes lies, damn lies, and statistics is when people make these changes without telling the world, or they make these changes in order to make the data look in a particular way. So what they've done is run through the analysis in lots of different ways until they get one which shows it in the gives the narrative, makes the point that they want to show. Then it becomes lies, damn lies, and statistics, because they then try to conceal that they made various decisions which change the way the data appears to people. That is common when politics and policy become involved with dealing with data, because you can cut your data in many different ways in order to try and tell a story. So in this case, probably I don't want to cut all those 3 out. It does do some nice things though. So it turns protein into this beautiful plot here with the interquartile range with the median bang in the center, which is just lovely. But if I go back and I do analyze, descriptive statistics, and explore, what was that? It was protein, wasn't it? What was that? And that was protein. And I get rid of all of the other categories and go OK. Now when I do protein, the median is no longer in the center of the interquartile range. It's the same as the 3rd quartile. So just changes of a few values can change the way your plots look and your graphs look. Now, yeah, exactly. It's frustrating. Another thing that was interesting to notice on this, let's go back to, so if we go back and look at calories, you've got 45, 46 and 47 all stand out as very strong outliers, and 4, 55 and 56 are also outliers. And if you go back and look at the data, 45, 46 and 47, they're all muesli. So muesli sits out at the top of the calorie values. And what was the other one? 54 and 55. So these, no, 55 and 56. So the puffed rice and puffed wheat come out at the bottom. Yeah, 55 and 56. In terms of the calorie content. So that rather suggests if you want to lose weight, don't go eating muesli. It might not be the best thing for you for doing that. Right, what else? So also going down, looking at fat, there's one outlier that really, really sticks out. So that's number 2. So what's number 2? So number 2 is 100% natural brown. Okay. 100% natural brown, it's got a measurement of 5 on its fat, but 100% brown's got 1, and so's all brown, and so's, well, all brown with extra's got none. So do you believe that value of 5? I don't really, do you? So again, this is just to show you what happens to the data. So I can go back and I can say variable view. I don't like that number 5 in fat. In fact, I just don't trust it. So I'm going to put a discrete missing value of 5 in, press OK. Go back to my data, go back to graphs, descriptive analysis, explore. So I'm going to put them all back in again. So now I've got another analysis where I've only got 73 things in here, and I've changed the mean amount of protein, and the mean amount of calories has pretty much gone back to where it was. But now for fat, the distribution's changed completely from the one it was before. Which is the best way of doing your data? There is none. Depending on your question, depending on the decisions you make, so long as you report that you're doing all the different steps that you're taking for dealing with it, then that's fine. But you must report what you chose to